Yeah, so I work as a sysadmin at Booking.com, and I'd like to tell you about our approach on scaling Graphite to handle millions of metrics per second. So first of all, basically we decided to try to solve several things with the Graphite. First of all, we really needed for capacity planning, and for this, you really need to store data for, well, quite some time, ideally forever. Also, we wanted to use it as a source of data for troubleshooting and sort of postmortems. And also because we already have this as a sort of time series thingy, we decided to store and visualize the business metrics. So whatever developers think is needed about the application, they also send it there. So this is our most common use cases for the system. And, well, the Graphite, we really liked the Graphite. We started using it, I think, in 2012 or even, well, or maybe 2013, so quite some time ago. And we, according to the graphiteup.org, Graphite do three things really well. It kickass, chew bubble gum, and make it easy to store and graph metrics. Indeed, it's really easy because it have a really nice HTTP API. You can query some endpoint and get the JSON out of it. If you want, you can get a PNG out of it. It's very easy to start using it. Like text protocol is, well, echo something netcat, and here it is. You can graph the thing you send. And it's also modular. You can basically replace anything you want, or do whatever crazy setup you actually want. And, well, you can get something like this if you want to. After years and years of scaling and trying to push it forward, we came up to, well, pretty big Graphite setup. It consists of hundreds of servers. Well, I can't disclose the exact numbers, but this is at least of order of magnitude of the stuff we have. It's have thousands of front ends, hundreds of terabytes of data, hundreds of unique metrics, unique series. We have more than 10 million unique points per second on ingestion, and tens of thousands of requests per second on both front end and on back end. And all those requests fetches tens millions points every second out of our storages from disk. And this does not include the stuff that's fetched from cache. And, well, if you will look on the original stack, especially back in 2014, you will see something like this if you want to have something more or less durable, something resilient. So you'll have several data centers, which will have exactly the same setup. You'll end up having Graphite Web on some bunch of servers or containers or virtual machines that talks to storage servers. And you'll have some relay, so some sort of load balancer on ingestion flow, where servers and applications will send their metrics. Back in 2014, there was not really much of alternatives to this kind of things. And that's why we decided to try to think what we do not like about this setup. So first of all, for this case, Carbon Relay was really a single point of failure for us. So the second problem was that for our cases, the backend does not really scale well. The Carbon cache used to use really a lot of CPU. Also, we do not like the disk usage patterns, of course. Also, there was no easy way to sync out data, if we have some failures on storages. So, for example, if one storage dies and the second one leaves, then the second one comes back, and users keep getting the different results every time they refresh. Depends on who answered first. And that's also lead to another thing, that the render request was really slow for us. So we decided to take a simple approach. We just decided to think okay, single point of failure is really bad, so let's try to fix this and try to come up with something that will work for our case. And that's how we ended in basically rewriting the relay in C. We decided to place a relay as close as possible to the producers of metrics. So basically every server have a small relay that knows about several bigger endpoints, basically several relays in each data center. We have These central relays knows about the storages. They know how to balance the metrics. They have some rules about like, let's get rid of these things, let's rewrite these things into something else, and so on and so on. So basically, the Carbon C relay is, well, as I said, written in C. It can. It was also really fast. It can consume more than 1 million data points per second using only 2 CPU cores, which was, well, really desirable feature for us at that moment. Well, it also knows about the Graphite line protocol, so it basically reads metrics, validates them, and decides where to send them out. It was also possible to do aggregations with it, but like, to be honest, at this moment we are trying to get rid of all the aggregation stuff in every place where it's possible. Yeah, and one of the most important stuff, it can buffer the data for quite some time if we have some like, network failure or node failure, and for most of the outages we do not lose anything and store basically everything that people send out. But the more backends we get, the more metrics we get, the more strange stuff we decided to started to notice. So first of all, like we saw that the metric distribution was not quite good with the upstream consistent hashing algorithm. So in worst cases, the difference was about 20%. So basically, when one server ran out of disk space or ran out of capacity, other servers was pretty fine. And well, we started looking around and decided like, well, we need to do something with this. And we found a really nice white paper from Google about jump hashing algorithm that basically allowed us to get almost even distribution. So the difference between, so in this example, these two graphs was from one of the last bunch of servers which got the old hashing algorithm and the new one. They are not really pretty loaded, but well, you can still see the difference. So the difference in with new algorithm is almost not noticeable. So you still can notice, but like less than 1%. And this we also implemented this in our relay. But recently we started to thinking that also the C implementation was not really easy to maintain for us, and especially because the original author left and maintaining this in his free time. And that's why we started an effort to rewrite the stuff in Go. Also, we decided to cover everything with tests, whatever is possible, because like, well, in Go it's much easier than with C. Yeah. We also decided to try to switch from the normal TCP, like the classical Carbon input and output, to start using Kafka. And also because we already do the validation, and from the developing perspective, validating the metric is basically means to parse it. We decided to send out data not in like line format, but start converting it to protobufs and send out in protobuf. But this effort is still not really ready for production. We are only playing with it and have some plans to deploy it on some smaller scale inside. But well, at least it runs somehow. Another problem we wanted to solve is the difference between the metrics. So in original stack in 2014, when one server dies and came up after a while, people will start seeing a difference. Every time they refresh the graph, they will see a different result. Because, well, two servers got a different amount of data. So we decided to take a really simple approach. We wrote a small proxy before the front ends that emulated the behavior of Graphite Web that fetches the data from all known backends that contain this metric, see if there is any gaps inside, and if there is any gaps, it will try to do its best to fill up the gap and present the user the full set of data. And well, after deploying this thing, we reduced the amount of complaints about, hey, I refreshed the graph and it's different now, what's happened, to almost zero. So there are still rare cases when it can happen, but well, almost not noticeable by normal people. And yes, we basically installed it in front of the Graphite Web on our front ends. And we also, around the same time, we decided to get rid of the carbon cache and replace it with something else, because it was, not really easy for us to maintain it. And we found a really nice open source project called GoCarbon. We contributed some code to it to allow it to read the metrics and present them in the way the Graphite Web was expecting them. It's now also part of the open source GoCarbon project since, I think, 2016, December or something like that. And also that solved some of the problems with speed of the queries, because in our test, the Graphite Web querying carbon cache allowed us to do something like 80 requests per second, and after writing the stuff in Go, it was almost 3,000 requests per second per each backend we got. And also, at that moment, the Graphite Web was unable to query the stuff in parallel. It was always sequential, so it's not like this nowadays, but, 4 years passed. And the zipper allowed us to query multiple backends in parallel, basically broadcasting the request like, hey, do you have this data? If you have, please give me for this time range. Another thing we also decided to rewrite in Go is the Graphite Web, but the part that's necessary for Grafana to work, because, Grafana, we installed Grafana, people really liked it, because it's much nicer than Graphite Web, and they started to using it, and basically by using it, they started to do the more and more complex queries, more complex dashboards, and that again became a problem from the perspective of speed and other stuff. And that's why we decided to implement the necessary parts, again in Go. And that also led to a quite significant decrease of the average response time from the front ends. So basically, this was the moment when we rolled out the Carbon API as a main data source for Grafana. And average response time reduced from something like 15 seconds to less than 1. I think it's not really average, but it was 99th percentile. But it led to some other consequences, because people started to do even more complex queries afterwards. Of course, because now the graphs became faster, and why not to start asking for more and more data. And this also allowed us to add some custom math functions to Graphite, because we really didn't want to touch the Graphite Web, so we tried to deploy the vanilla version in 2014. But when we control all the code and when we can do whatever we want, we basically can implement whatever we want in terms of math. And at some point we also decided to make all the functions and parsing stuff available as Go libraries. So there are some projects that uses our libraries. So as far as I know, there is a streaming alerting for Graphite data called Moira, which uses our library to do the math. But not a lot at this moment. Another thing we started thinking is, quite simple and maybe obvious thing, but when you have a backend and you want to store the data, one of the approaches to do, you want to have some resilience and to be failure safe and so on and so on. And one of the common approaches is to go for replication factor 2. Basically, whenever the metric comes, you hash it once, decide okay, this will go to server 1. Then you get rid of the server from the hash ring, hash it again, and say, okay, now it goes to another server, and send it, write it twice. But the problem we faced was that we were using the bucket tools to manage to do the operational work on Graphite, and the bucket tools do not really work with replication factor 2 for some unknown reason. And we decided to see maybe if maybe it's worth to switch to replication factor 1, and on relay level just send it twice to split our server fleet manually into 2 parts equal, and send it out basically to different parts. And and the second thing is like, okay, and what if we will hash for the second part differently? So which of these three approaches will be actually better for our needs? Well, we ran some experiments, decided to compare it by, well, first of all, we decided to count how many data we will lose in case of, like, in worst case of a failure. So for example, the 2 server fails, each of them will in the first part, the 1 server fails, and in the second part, the same server fails, it contains the same metrics. And, well, quite obviously, for replication factor 1, you'll lose a quarter of data for 8 servers. For replication factor 2, you will lose something like 3.5% of data. But what about the probability to lose this data? So for replication factor 2, if you have, if 2 servers fails, then you'll obviously lose something. So it will be a small percentage of data that's not available, but it will always be. In case of replication factor 1, the probability to lose the same server that have the same set of data in both groups is, well, quite low, and is only like 15%. And, well, randomized one is so like if you compute the hash differently, it's, well, a little bit in between. And we actually decided to go for replication factor 1 and 2 different sets of servers, because at that time we got not really reliable hardware as storage nodes, and they were failing quite often under the Graphite load, and that's why it was important for us, like, to reduce the probability to lose data. Then, of course, we decided to do some sort of simple tags. They are not compatible with what the Graphite have upstream, well, at least not at this moment. But we actually want to do it compatible, in a compatible way. But, well, we got this since, I think, 2015, I think. So we decided to embed the tags in the metric name, not in the, so like basically create a virtual requests that will do something like data center 1 and status live and role equals storage, and also do the text filtering afterwards. It got some limitations because it do not have anything like negative matching. It doesn't have anything like OR syntax. It also do not really have any history. Well, didn't have any history, at least. But it allowed us to do it in the way that was compatible with Graphite 0.9. And yeah, but we really want to switch to something else. And well, another bunch of problems. So we got hundreds of servers and people, and sometimes you get something like, well, alert, disk space usage, only like 10% left, please provision a new server. But the problem is that, well, you checked it 5 minutes ago and it was like 20% left. So who the hell created all this new strange stuff? Because like the Graphite with Whisper have one drawback, that it preallocates everything on disk. Like you can use sparse files, but well, there will be consequences of this if we decided to do that. And that's why we didn't have sparse files like at all. And sometimes people, and because it's really easy to send data to Graphite, it's really easy to abuse it. For example, you can start sending, like instead of the variable name, you can by accident get the address of variable and send it instead. And every instance of your application will create a bunch of strangely named metrics. And you never know until you actually encounter something like that. Or, for example, some A/B testing or, well, pen tests or something like this can create a bunch of metrics that wasn't there before. And, well, we decided to start collecting all possible stats about our backends. So basically all the meta information we can get about the file, so when it was last time accessed, when it was created, what's its size, and then, like, as part of some hackathon project, wrote a simple web page, so grabbed one library from GitHub, adapted it to our needs, and started presenting the disk space in the way like flame graphs. This allowed, like, for example, one of the real flame graphs. So this was the disk usage before, and at some point, well, something is created. When you have something that can be considered as a good data point, it's really easy to switch to the next one and see the difference. So like you can easily spot where it happened, and that's how you can see, like, okay, is this metric actually a legit one, or it's somebody created it by accident or something like this. This also allowed us to do a lot of analytical queries across all the data set. I mean, how people use our stack, what metrics are like the most commonly asked, what nobody cares about, they just send it for like just in case, and so on and so on and so on. So there was actually really nice values like that. Around 99% of metrics nobody cares about. But the last 1% is something really hot, and well, we can do some optimizations based on that, for example. And as a bonus thing, that we adapted the same stuff to get something like stack traces from the same graphite stack in, well, more or less real time. It's not really useful for like outside, because I'm not really good in terms of JavaScript programming or UI design, but you can easily get something like this and refresh it like over time and see like that. Okay, this is something from Go runtime that took the time, or something like this. So it's really useful when you do the debugging or something like that. Well, of course, we have some plans on what to do with it next. First of all, we really want to find some replacement for Whisper, because, well, it doesn't have any compression. It's 12 bytes per point, so it takes really a lot of disk space, and most of our backends are actually disk space bounded, not CPU or memory or network bounded. Like, we are trying to replace the Graphite line protocol between the components, because like on read, nowadays we use protobuf, and we are looking forward to migrating to basically streaming gRPC there. But in terms of ingestion, it's still line protocol across all the stack. And after basically deciding, like, well, after the first step, you don't really need it. And you can use something that's compressed and even binary, not to spend the CPU time on the backends. We want to actually make the flame graphs more or less production ready for other use cases, and for example, do something, not switch between the two timestamps, but have something like differential flame graphs. But well, again, I'm not a JavaScript programmer, unfortunately, and don't really have time to implement this stuff, but still. And we also, at some point, we wanted to start collecting the stack traces from the Graphite stack, basically in production, to get some information, like insights about what's happening under the hood when we face some problems. But again, there's still like stuff in progress, and the stuff we really want to. And we also decided to, like, from the beginning, everything we've done was basically open source project. So everything that we've done is on GitHub, and there are a bunch of, well, projects there. Since I think previous year, we decided also to create a GitHub org that will basically consolidate all the projects, because before that, all the projects was on its own developers' internal, like, own GitHub account name. Yeah, and actually it was really surprising for us that not only we use our stack, but also, as far as we know, some parts of stack is used by eBay Classified, and in particular Mark Platz. Also on previous Monitorama, the guys from Slack told that they use, again, parts of our stack. And, well, maybe somebody else, but they're not telling us about that. Yeah, and any questions? Yeah. Yeah, let's wait for the microphone.
How do you handle the failover for aggregation at the carbon C relay level?
Well, at this moment, that's one of the reasons why we are encouraging people to get rid of the aggregators, actually, because we done really a lot of effort to make these things fast, and we encourage people to use raw data whenever it's possible, because when we got aggregators, it's really hard to make it fast and failure safe. For some time, it was we get an aggregator in each data center, and each aggregator received the full data set and saved it locally in data center. But because we were aggregating on streams, sometimes we got some difference between the points because they arrive in different order, or like there was some problem and it didn't arrive in the second data center. It was really painful to decide which one is actually a good one. So yeah, we do not have the high available aggregators like at all.
Any other questions?
Yeah, it's
making me have to run.
Hey, I can understand the final infrastructural drawing about the, if I'm not mistaken, Gorelka or something like this, on the go, relay on the go.
Yeah.
Can you recommend it? It works nice, and have you this stable infrastructure, or are you scaling your Graphite servers under it? Carbon API with Go Graphite, I mean, with Go Carbon, I'm sorry.
So I don't remember if I have the final one in the slides, but I think I should have one. Or, well, the simplified version. Well, the Go Relay, the Gorelka, we are still working on it. We want to replace Carbon C Relay, basically start replacing it this month or maybe next month in our infrastructure, so it like works, but it needs some features. For example, it do not behave well when you when something down and then sends a lot of data in batches, in really big batches, so it do not have the throttling yet. And this, I think, one piece, like the last piece that we miss here. And with the scaling, well, on each front end we have Carbon API and Carbon Zipper still, even though that Carbon API actually can do most of the Zipper stuff at this moment. But like, well, every front end have exactly 3 pieces of software: Grafana, Carbon API, and Carbon Zipper. Grafana just for historical reasons, because it's really lightweight, and we just decided to couple it with Carbon API. And whenever the front end is a problem, we just deploy a new server that contains these 3 pieces. For the backend side, it's always Go Carbon with a Carbon server enabled inside. Yeah, it's always a single process, and whenever we run out of disk space, or like, well, in rare cases when we hit the limits in terms of capacity, like, I mean, amount of metrics per second we can receive on storage side, we deploy a bunch of new servers and do the rebalancing with bucket tools, basically. Any questions?
Any others? Going once, twice? Okay. Round of applause, thank you.